All right, we're going to continue our work on Unit 1011 here, where we're looking at data. And today we're going to look at a different kind of graph that are called scatter plots. You've probably made scatter plots before. But we're going to go through the process of making them again and talk a little bit about how we're going to use them. And one of the things that we're going to be able to want to be able to do with our scatter plot is drop a line of best fit on it. So we're going to look at those two topics today. So hopefully by the end of this lesson here, you'll be able to, first off, identify the dependent and independent variable in a situation. We're going to talk about what those two words mean. And then we'll get into constructing scatter plots. We'll do an example by hand. And then after this, you guys are going to do an investigation where you will do it using technology. So you want to have the Desmos app downloaded on your iPad if you don't have it downloaded already. And then once we have our scatter plot, we are going to use our scatter plot to figure out whether there's a relationship between our variables. And we want to be able to describe that relationship and talk about the type of correlation that we see. So that's another word that we're going to talk about. And then once we've got our scatter plot and figured out if there's a relationship, we're going to want to be able to draw a line of best fit on our scatter plot. We draw it by hand. Or if we use technology, we want to be able to put it on using technology. And if we use technology, we'll be able to find the equation of the line of best fit, which is going to be helpful to us when we're doing mathematical modeling. So let's take a look first at those, just some general stuff around scatter plots. So we use scatter plots to look for a relationship between the variables in a set of data. So we always have two variables that we're looking at here. And we want to figure out whether or not there is a relationship between them. As one of them increases, does the other one increase? As the other one decreases, does the other one increase? Like, the way we do this is we take our data, or our variables, we plot them in our scatter plot, and we look for a trend or a pattern that we see in the scatter plot. And that tells us whether or not there is a relationship between the variables. Now, we always have two variables that we're working with, and we're always going to call one of them the dependent variable and the other one the independent variable. And it's important to make this difference at the beginning so you can get your scatter plot set up correctly. The dependent variable, well, it depends or is sort of determined by the independent variable. And we always plot the dependent variable on the y-axis, or on the vertical axis of our scatter plot. Our independent variable, we can say that it does not depend on the other variable. And generally this means that we have some kind of control over this area, or it determines what is going on. This is the variable that determines what is going on in our situation. Okay? It always gets plotted on the x-axis or the horizontal axis. Okay? So let's sort of just jump in this situation here, and we'll figure out we'll look at how you figure out which one is the dependent and which one is the independent variable, and then we'll go ahead and make our graph. So the example we're taking a look at here is my daughter had a birthday party, and as each child left the party, they took candy from a bowl. So there's a big bowl of candy. They take however much they want as they're walking out the door. So every now and again, I checked to see how many children had left. And I also checked the number of pieces of candy that were left in the bowl. And I didn't do this as every kid left. I just sort of recorded these numbers at periodic intervals here. So first off, what are the two variables in this situation? Well, obviously they are number of pieces of candy left. So it's a number of pieces of candy left is our one variable, and our other variable is the number of children who have left. We'll just call this children who have left. Now, I want to figure out which of these is my independent variable and which is my dependent variable. So what I do is I ask myself, does the number of children left does that depend on the number of pieces of candy? Or does the number of pieces of candy depend on the number of children who's left? Which one of these makes more sense? So if we look at the first one here, that the number of children who have left depends on the number of pieces of candy, that would mean that as we took candy out of the bowl, it caused children to leave. Okay? It means that the number of pieces of candy determines how many children have left. Okay? If we look at the second one, then the number of pieces of candy left in the bowl is determined by how many children have left. So that as children leave, it changes the number of pieces of candy. And I think when we put it this way, it makes more sense. Okay? So if the number of pieces of candy depends on the number of children who's left, then we know what is our dependent and our independent variable. Our dependent variable is number of pieces of candy. And our independent variable is number of children. Who have left. So now we want to take this data and we want to turn it into a scatter plot. So we've got our grid here. We know that our independent variable is the number of children who have left. So we're going to plot that on our horizontal axis. So down here, this is going to be the number of children who have left. Because it is my dependent variable, my independent variable. My dependent variable goes on the vertical axis, or the y-axis. So over here, we're going to have number of pieces of candy left. Okay. So the next thing I want to do is I want to put a scale on my axis. So to do that, I'm going to flip back and I'm going to look at the numbers that I have here. So for number of children who have left, my numbers go from 3 up to 13. So if I go back to my graph here, I want to be able to fit the numbers from 3 to 13 along the horizontal axis here. So I'm probably going to want to start at 0. And if I count them up, I've got 20 spaces here. So a good scale is going to be each little box represents one child. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I can go up to 15, even though my numbers don't go that high. When I look at number of pieces of candy, I need to get up. I look for my biggest number. My biggest number here is a 33. So I have to get numbers up to 33 on this grid here. I only have 20 squares again, so I'm going to have to go up by 2s every time in order to get 33 in there. Because if I have 20 spaces and I go up by 2s, I'll get up to 40, which is enough for me. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 6, 8, 30, 32, 34, 36, and so on and so on. Okay, now I'm going to plot the data that I see in that table. So for my first data point, number of children who left is 3, so I want to find 3 down here on my number of children axis, and then pieces left in the bowl is 33. So I'm going to go up to 33 is right there, and that's my first point. My second point, number of children is 6, so I find 6. And then I go up to 25, and that's going to be right there. Our next point is 8, 21. Right there. Our next point is 9. So 9 is there, and then 20 is right there. And then our last point is 13 and 12. So 13 is there, and 12. Okay. So there is my scatter plot. Now, is there a trend or a relationship? And yeah, what we can see in the data is that the points start up in the top left and they go down to the down and sort of all fall down. They're gradually getting less and less as we go from left to right. So describe the relationship. Okay, so we could say that as the number of children, as more children leave, which is what we're seeing as we go from left to right on that horizontal axis. I mean, the number of children who are leaving is increasing. As more children leave, the amount of candy decreases. And that's what we see in this graph as we read this graph from left to right. Okay, we start with a large amount of candy with few children left, and as we go towards the right, things kind of fall. So next up, we need to draw a line of best fit. A line of best fit is just a line that illustrates that trend in the data. So I'm going to get myself a line here, and then we will talk about how you add it on here. Okay, there. I've got myself a line here, and you're going to do this with a rule. Okay, so I can take my line here and I can move it around, and there are sort of two things I can change about a line like this. I can kind of move it up or down, or I can change the angle that it's at. Right? So what I want to do is I want to change the angle or slide it up and down so that this line sort of passes through most of the points that I have. Okay? And that's not going to pass through all of them, but I want to get it so that it passes through most of them, and all the other points are as close to that line as possible. So that might be as good as I can get sort of right there. Almost all of those points are just touching that line, and it sort of illustrates that trend that we talked about. That as the number of children is increasing, the number of pieces of candy is decreasing, or the data points are going down as we go from left to right. Okay? So if you're doing it with a ruler, you just want to sort of put the ruler sort of along that sort of line of points, and then draw a nice straight line through all of them. So that is our line of best fit. Now, we have one last thing that we want to talk about here, and that's this idea of correlation. Okay? So correlation is just a fancy word saying that there is a relationship between the variables. In mathematical terms, if a change in one variable produces a proportional change in the other variable, then the variables are correlated. So we've got three graphs here. This first graph is showing price as a function of age, or how the price of something changes over time. If we were to draw the line of best fit here, we would draw a line something like this. Okay? This is what is called a negative correlation. And because as our age increases, so as we go along this way, our age is increasing, the price is decreasing. So that's a negative correlation. In our next graph here, we've got points per game and rushing yards per game. We get some football statistics. If we were to do a line of best fit here, we might do a line kind of like that. And it goes right to that trend in there. This is a positive correlation. Because again, as points per game here increase like this, what's happening to our line? Our line is going up. So we have a positive correlation. In our last graph down here, we just have X and Y. This is an example of there being no correlation. And because we don't really see that nice little trend in the data, we just see the sort of points that are scattered all over the place. So if we come back to our example here, do we have a positive correlation, a negative correlation, or do we have no correlation? Well, the fact that we've drawn our line here suggests that we definitely have a correlation. Things are falling, our line is going down as we go to the right. So this is an example of a negative correlation. Okay. And that's scatter plots by hand. So the next thing you're going to want to do is look at how you can do scatter plots and all of this stuff using technology. So there is a investigation in the learning guide that uses the Desmos app on your iPad that you should work your way through to make sure that you can use scatter plots using technology.